The next easy step while assembling BITX according to the manual is fixing 5 numbers of 1N4007 diodes in the slots shown on the top of the board silk screen. Polarity is shown in the print by a ring marking which has to correspond with the silver ring on the black diodes. These diodes are rated for 1 ampere maximum continuous current. All the 5 diodes have been soldered in position. Continuity with circuit from the soldered spot has been checked using my digital multimeter. Now let us see why these diodes are there in the BITX circuit. D16 is the reverse polarity protection diode in series with the power supply. Protects the transceiver from permanent damage if the DC power supply is connected with reversed polarity, plus minus swapped. Some are flyback snubber diodes used in relay circuits. They are placed across coils to absorb high voltage back EMF spikes that occur when the relay is turned off, thus protecting the switching transistors. In the schematic of BITX, you can see that D13 shown in the picture is connected across the coil of RL4 relay, which switches between 40 meter and 20 meter low pass filters. It protects the switching transistor 2N3904 labeled as Q16. 1N4007 has 1000 volts peak inverse voltage rating, making them very robust against spikes. There are a total of 15 2N3904 transistors to be soldered in the BITX kit. With a transition frequency of around 300 MHz, they can be used in audio and radio frequency stages. They can be used for transmit-receive switching, audio mute function while transmitter is in operation, audio pre-amplification, buffer amplifier, and to compensate for signal loss through filters. They are intended for low power use as their maximum rated collector current is only 200 milliamperes. Print on the silk screen will show the shape of the transistor as seen here. Hence, it is easy to mount them looking at the picture alone. Leads have to be separated slightly to go through the holes exactly. I am trying to see if I can show you the print on the transistors. Numbers printed on them can be seen now with better illumination. Print is on the flat side of the transistors. You can see Q9 and Q10 printed on the silk screen in this zoomed view. Shape corresponds to that of the transistors, enabling correct placement of the leads. Q7 transistor has been placed in the slot with alignment as shown on the silk screen. After placing the transistor in the slot and bending 2 leads at right angle, I usually nip off the center lead and solder it first so that the transistor gets fixed to the PCB. Then the other 2 leads are nipped and soldered sequentially to complete the process. Continuity from the solder spot to the nearest point on the PCB circuit is then checked to make sure that the solder joint is good. So far I have fixed 6 transistors and 9 more to go, excluding the final RF power transistor. RF power transistor is IRF 510, which needs special assembly with a good heatsink and heatsink paste. That is at a later stage according to the BITX manual.